In the name of Allah, in this lecture we will explain in a simplified way the most important advantages, disadvantages, and general remarks about the distribution network, whether it operates using the radial system or the ring system. As I mentioned in the previous lecture, the ring distribution system begins from switchgear 1, which supplies the first kiosk transformer in the ring system, and it ends at the last kiosk transformer, then finally connects to switchgear 2. I also explained earlier that one of the most important components of the kiosk transformer is the ring main unit, RMU, which is considered the core element in the operation of the ring distribution system. We have learned that the ring main unit, RMU, contains several load break switches, LBS, used for both the incoming and outgoing medium voltage, MV, cables in the ring distribution system. As we can see, all the load break switches, LBS, in the ring system shown in front of us are closed, except for one load break switch, which is normally open. This means that switchgear 1 will supply transformers number 1, 2, and 3, while switchgear 2 will supply transformers number 4, 5, 6, and 7. From this, we can understand that in the ring system, each switchgear is responsible for supplying a certain number of transformers within the ring network. And this arrangement requires the existence of one load break switch in the open position. Now let's assume that for any reason, a fault or short circuit occurs on one of the medium voltage cables, for example, on the MV cable between transformers number 4 and 5. In this case, we will observe the first main advantage of the ring system, since transformer number 4 is supplied through switchgear 2. The occurrence of a fault on the MV cable will cause transformer number 4 to lose its electrical supply completely due to both the faulty cable and the open load break switch on the switchgear 1 side. Therefore, the first and most essential step is to isolate the faulty MV cable to enable its repair while restoring power quickly to transformer number 4. The procedure will be as follows. First, open both load break switch number 8 and load break switch number 9 to completely isolate the faulty medium voltage cable from the power supply, allowing maintenance or repair. Next, close load break switch number 7, and in this case, transformer number 4 will be resupplied from switchgear 1 instead of switchgear 2. Thus, the most important advantage of the ring distribution system is that in case of a fault or short circuit in any section of the ring, we can isolate the faulty part entirely using the load break switches and at the same time continue supplying power to the remaining components and transformers of the ring system without interruption. However, in the case of the radial distribution system, the supply is taken from only one source or a single switchgear, unlike the ring distribution system, which is characterized by supplying all transformers through multiple switchgears. Therefore, if a fault or short circuit occurs on one of the medium voltage MV cables in the radial distribution system, unfortunately, as shown in front of us, we will observe that transformers number 3 and 4 become completely de-energized. This means that the faulty cable has caused the loss of supply to transformers 3 and 4, and consequently, the faulty cable must be repaired first before the transformers can be supplied again with the required medium voltage. In other words, transformers 3 and 4 will remain disconnected and without voltage until the faulty cable is repaired. This represents the most significant disadvantage of the radial distribution system. But the important question is, should we always have at least one load break switch, LBS, in the open position, or is it possible to close all the load break switches in the ring system? Of course, it is absolutely necessary to have one load break switch in the open position within the ring system, because, as we explained earlier, the ring system is supplied from two sources, which are power transformers located inside the high voltage substation. Therefore, if all load break switches are closed and for any reason a fault or short circuit occurs on one of the medium voltage cables in the ring system, we will notice that the fault current, short circuit current, will become very large. This happens because the short circuit will be fed from two power transformers, meaning two different sources instead of one. As a result, the fault current will increase to a very high value, which is undesirable. That is why keeping at least one load break switch open is essential. It helps to reduce the short circuit current as much as possible. It is also extremely important to keep one load break switch open, because if all load break switches in the ring system are closed, this means that the two power transformers, number 1 and number 2, inside the high voltage substation will be connected in parallel indirectly, that is, through the distribution network and without the knowledge or supervision of the personnel in the high voltage substation. The problem here is, are the two power transformers, number 1 and number 2, inside the high voltage substation suitable to be connected in parallel, or are the parallel connection conditions not fully compatible? Of course, everyone knows that there are basic conditions for connecting transformers in parallel. It is possible that the two power transformers, number 1 and number 2, have the same voltage rating, the same frequency, the same vector group, and the same phase sequence, R, S, T. However, there might be a difference or mismatch in the impedance voltage, Z%, and this can cause a serious problem in load sharing between the power transformers inside the high voltage substation. Therefore, it is extremely important to keep at least one load break switch open within the ring system in order to avoid any technical problems in the electrical network, whether they are technical issues in the medium voltage distribution network, in the high voltage transmission network, or even inside the high voltage substation itself. Thank you for your attention. See you in the next lecture.